Hi everyone. In this video, we are going to discuss about the Kirchoff law. Kirchoff law is classified into two forms. They are Kirchoff's current law and Kirchoff's voltage law. Where Kirchoff's current law states that at a junction, this point is considered as a junction. At this junction, the total current flowing towards the junction. Flowing towards means that incoming currents, where I1 and I3 are incoming currents, is equal to the current flowing away from the junction. Away from means out of the current which are flowing out to the point is said to be the away from the junction points. So simply the Kirchhoff law states that at the current entering to the node is equal to the total current leaving from this node. By analyzing this the diagram, we are considering I1 and I3 as an incoming current, where I5, I4. Then by applying KCL means Kirchhoff's current law, to this figure, we are getting I1 plus I3, where I1 plus I3 are incoming currents, is equal to I2 plus I4 plus I5, where these are the outgoing current. By equalizing this, we get I1 plus I2 minus I3 plus, so by equalizing this, we are getting I1 minus I2 plus I3 minus I4 minus I5 is equal to 0. Then Kirchhoff's voltage law. In any closed network, this closed network, the algebraic sum of product of current and resistance across the circuit element of any closed path is equal to the algebraic sum of the EMFs in the path. It states that in a closed network, consider this closed network having the sum of products of currents. In this circuit, the currents are represented as I, and the resistance are R1, R2, R3 and R4, where voltage supply is represented as E1 and E2, where the voltage drop across these each resistance of this closed path is equal to the sum of the EMF in the path. In other words, it states that in a closed circuit, in this closed circuit, the sum of the potential rises is equal to the sum of the potential drops. Where by using KVL means Kirchhoff's voltage law, to this circuit, we are getting E1. E1 is the voltage across this resistance R1 minus I into R1, current I into R1 minus I into R2, current into resistance 1 minus current into resistance R2 minus current into resistance R3 minus current into resistance R4 plus E2, the another voltage supply. Where E1 and E2 are voltage supply, we are transferring and getting that in one side and taking I as a common one. So I is equal to R1 plus R2 plus R3 plus R4, where voltage rises, E1 and E2 is in plus. So voltage rises is equal to sum of the voltage drops. So sum of the voltage across these R1 and R2, R3, 4 can be calculated by using this KVL or Kirchhoff law. Steps to solve KVL and KCL. First, KVL. KVL is to identify closed loops in the circuit. In the circuit, first step is to identify the closed loops in that circuit. In KCL, first step is to identify the junctions in the circuit. So we need to assign polarities to each component present in that circuit. Then in KCL, label circuit currents entering and leaving each junction. In KVL, the step 3 is choose a direction for loop traversal. In KCL, step 3 is write an equation for each junction summing the currents. In KVL, step 4 is traverse the loop, nothing the polarity changes. We have to traverse the loop without changing the polarities. In KCL, to set the sum of entering currents equal to sum of leaving currents. Then KVL. Step 5 is write down the voltage drops and rises across each component. In KCL, solve the resulting system of equations to find unknown currents. Then in KVL, step 6 is sum up the voltage changes and set it equal to 0. In KCL, verify that the sum of entering currents equals to sum of leaving current. These are the 6 steps to solve the KVL and the KCL.